All right, as I was saying, hello everyone and welcome to the June 24, 2021 OpenShift Meetup. I'm Joseph Tihak coming from Wellington, New Zealand, and I'll be your host for today. And we hope everyone is going well, all keeping safe, especially all of us here in Wellington. Hang in there, folks, should be all right. So we've done this before, so it should be pretty good for us. And joining me today is Michael Calizo and Asher Benjamin from Auckland from
Hey
our
everyone.
solution architecture team. They are familiar faces of OpenShift Meetup. Hey, Mike, Ash, what's up? How are you guys coping?
Good, man. Hope everyone's doing well. And like Joseph said, stay safe, especially the people from Wellington.
Yeah.
We're thinking of you.
Embracing the work from home again, so no problem for me at all.
Hey, Michael, did you get your stash of tissue paper?
No, not yet, but maybe
Not
later
yet.
on.
All right. Yeah. All right. So just before we start, a bit of standard housekeeping for the meetup. We are recording this session. Link will be shared with everyone on the meetup page when it becomes available. And of course, let's make this interactive. Chat and comments goes into the chat section. That's the bottom right corner. And go ahead, test it out now, quickly saying hi to everyone. Some of you already did. And probably tell us where you're from. I know some people are joining us from Australia. Uh, Welcome, mates, on the other side of the Tasman. Thanks for joining us. And the thing about Meetup is that we tend to forget that it's a great place to make friends as well. So make use of that, chat, share your ideas, collaborate. We'd love to hear your reactions and violent reactions and whatnot. So make it interactive. And don't forget that you can also request to participate on the main screen discussion. You can click that button and we will allow you to join us on the screen if you want to speak for a bit or probably something you share. And the questions, post your questions on the Q&A box, also on the right side of your screen. We will try and answer these questions during the presentation or towards the end. Polls. We will be creating polls during the session, so keep an eye on those, and we'll be happy if you participate in those questions. All right. And again, before we go to the main topic, please know that everyone is welcome to speak in the meetup. If there is something that you're working on that you want to share, we will be happy to collaborate with you and have you as our speaker. So please feel free to let us know. And for today's topic, Mike and Ash, today we will learn more about Red Hat Advanced Cluster Security for Kubernetes, formerly known as StackRox. What do you think about our topic today now, Mike and Ash? Pretty timely, eh?
I think that's awesome to have Eric in this meetup, Joseph, because I think security as a topic, especially on a container platform, as well as in the Kubernetes platform, is very important. With the recent, cybersecurity issues
I
that
know,
we
right?
had encountered, and it's getting serious because those bad guys are becoming more technical and more strategic in their attack. So
That's
to
right.
handle that problem, we basically need to have a proper security in our implementation.
That's really cool. And as we all know, to be more specific, Michael, containers and microservices nowadays it initiated a huge shift in application infrastructure, and of course, Kubernetes has emerged as one of those most quickly adopted technologies ever. And because of that, it's going to be a major task for us to make sure that everything is secured in what we would term as a cloud native approach. And we need a security platform that protects our entire Kubernetes environment. And on that note, we are joined today, as Mike said, by no other than Eric Bannon. Eric, are you there?
I'm here. Yeah.
Awesome. Now we can see and hear you. I've heard you were saying that there's a heat wave in California where you're from, eh?
Just like 100 degrees the last week.
Oh wow.
Been good, but cooling off now.
That's good to hear. We are starting to freeze here on the Southern Hemisphere. But just a brief introduction about Eric. Eric is our senior specialist solutions architect at Red Hat, focusing on Kubernetes security. He's a business-minded solutions architect with more than 10 years of hands-on implementation experience in, I would say, virtualization, enterprise IT operations, public cloud design, and complex container initiatives like Kubernetes, Mesos, and Docker. He might be a familiar face to you outside of Red Hat. You know why? Because Eric is part of the original amazing team at StackRox, which most of us know has been acquired by Red Hat recently. And outside of work, Eric loves to hang out with his dog. Hopefully, we get to see him on the screen later on. And as you probably see on the background, he loves playing acoustic guitar and doing outdoor stuff and also getting involved in the community. So that's my introduction about Eric. Probably he can tell us more about himself and the dog and the guitar. Over to you, Eric.
Yeah, sounds good. Thanks, guys. Yeah, I don't know if you'll see the dog, but you'll definitely hear him because he typically likes to bark when I'm on meetings. If mailman comes to the door, as we all know, with Amazon Prime these days, it's like Christmas every day. I get gifts from Amazon. I don't even remember ordering myself, so he'll probably bark. But yeah, no, thank you for the introduction, guys. I think for today, we'd like to keep it really, conversational with everybody on the meetup. Obviously, it's more of a casual setting, but my plan is really just to lay the table in terms of really why I think Red Hat acquired StackRox, and that really comes down to kind of a security vision for Red Hat in general, and an alignment that I think Red Hat really had on security being built in versus bolted on. I think that when I think of like the security mindset of Red Hat and what they've done with Kubernetes and OpenShift, before anyone else was really thinking about security, they were already thinking about, building it in a way that's enterprise ready with things like SE Linux, default container isolation, building default roles and privileges, and this idea of least privileges and network policies. And, so all those platform level security characteristics you would expect in infrastructure. Now, the question is, how do you elevate that approach to the applications, and the containers you're specifically running on top of OpenShift. And I think that's really the gap that StackRox or ACS is beginning to solve. Can you guys see my screen? You should be seeing a slide.
Yes,
sure.
Yes.
You're seeing continuous security. Okay, great. Yeah. So what I'll do is I'll kind of go through a little bit on our security mindset, the security philosophy of StackRox. If you hear me call it StackRox, it's the same thing as Red Hat ACS. But what I'll probably do is I'll probably spend most of the time in the demo. But this will give you kind of a good idea. What's currently offered in OpenShift. What value does this add? What does it solve from a security perspective on top of OpenShift? And why was this strategic for Red Hat, and why I'm personally, honestly, I'm really excited to work with Red Hat and work at Red Hat, because I think that when you marry our security approach to what you're already doing with OpenShift, it's a win-win. You're covering everything from the operating system and the worker nodes and the platform level infrastructure that you're running with OpenShift. And then you're taking a top-down approach of application and container-based security with ACS. When you put those two together, it's like peanut butter and jelly, right? You have full stack security, full lifecycle security across everything. One of the big premises, and this is something that's going to be central to everything we do, is that we made a decision as a company, StackRox, that is, about 4 years ago, to only focus on Kubernetes in terms of the way we look at security. So that means, there's a lot of things we're not designed to do, right? We're not designed to be a web application firewall. We're not designed to do virtual machine-based security and looking at VMs and legacy things running on virtualization outside of Kubernetes or OpenShift. We're not trying to do, we're not a DDoS solution. We're not trying to solve every security domain under the roof. And the reality is that in security, they're going to have multiple security products that are designed to do different things. There's not going to ever really be, the one tool to rule them all, so to speak. But that being said, when you think fundamentally of what you need to secure running on OpenShift or Kubernetes, the life cycle of your microservices and how that runs and how that's being built, how that's being deployed on Kubernetes is what we focus on. And we made a conscious decision before, the container wars were won. So you had other security products in the industry that were doing, VMs plus containers plus different orchestrators. And really the idea that we wanted to take advantage of was like, okay, how do we don't want to just be like solve 20% of the use case and support, all these different platforms, but only go an inch deep. The easiest way to think about what ACS does or what StackRox does is we turn your Kubernetes or OpenShift orchestrator into a security orchestrator. So the idea there is like, okay, we've all heard the term DevOps, and from an operations perspective, if I can declare what type of infrastructure I want and I can press a button and I can have that provisioned through OpenShift or Kubernetes, if I'm a developer and I can say, I want my application to have this amount of CPU, this amount of memory, I want it to run this way, and I can declare that in code and configuration and run it on Kubernetes. The question now becomes, why can't security be the same? Why can't a security team say, I want to run my microservices this way, I want to declare that in my orchestrator, I want to declare that as part of my build, deploy, and runtime policies, and I want it to just run that way. So I want to be able to define, what good looks like, and the only way to do that is if you use the orchestrator, the same thing that your developers and your operations team is using, as the single source of truth, and that's what we do. There's two important aspects to that. The first is context. You need to know how something is going to run or is running in a Kubernetes or an OpenShift environment. Like, in other words, you could have a vulnerability that's super critical, but if it's running in test dev or staging and it isn't exposed to the internet, it has no roles or privileges allowed on it, and it's basically doing one or two things and it's not very busy or suspicious, that's not as bad as the same vulnerability in my image running in production, running on a publicly exposed load balancer with a secret exposed as a plain text that gives someone maybe credentials to like my AWS access key by accident. I've seen it. It happens. And this is the reality we live in, is that with declarative configuration on OpenShift or Kubernetes comes a lot more room for humans and developers and people to maybe do things that aren't intentionally bad, but present security risk. And that's one I think when we talk to like CISOs or we talk to CIOs, that's one of the biggest like fears moving to containers is like, well, how do we secure this? We have everything in source control now. We're building everything this way. Like, how do we make sure that we're doing it correctly and we're not just like spinning out applications that leave us exposed to maybe ending up on, the national news? And that's like the biggest fear I think that organizations have. Well, you need to take a contextual approach, right? The way that attackers view Kubernetes is contextual. And so, you're only as strong as how well you secure your entire supply chain and how well you secure that entire environment. And therefore, images and containers, yeah, that's important, but it's only one attack vector. You have to look at every other dimension to how your application is going to run. And so the second advantage to this is that everything uses the native APIs and the native primitives for OpenShift, meaning we don't introduce some like enforcement mechanism or proprietary mechanism to do security enforcement that Kubernetes or OpenShift doesn't understand. I'll give you like a really good example. There's a lot of vendors in the industry that go, we have a container native cloud firewall, Kubernetes, and what they're doing is they're running an inline proxy with read-write privileges on all your worker nodes that basically is using IP tables to block connections that come into Kubernetes. To me, that's the most non-native thing in the world for Kubernetes. That's like basically the quickest way to a denial of service running on OpenShift is if you try to apply some sort of monolithic firewall or networking mechanism to Kubernetes when OpenShift expects you to use things like network policies, CNI provider, or even the OpenShift service mesh. there's all these new container native ways to do software defined networking, and that carries over into other aspects of how you want to look at security. You don't want to just look at, the monolithic application world where all of your logic was happening outside of the application. Well, now everything's configured and is tunable from the beginning. And that gives a lot of power and advantage to security teams who can come in and not just try to, play whack-a-mole with risks, but actually say, how do we shift things left? How do we build this into that? Well, the only way you're going to get adoption from developers to do that is if you do it in a way that they expect, meaning use the API server for OpenShift, tell it what to do, quarterback it, tell it to do this here, tell it to do that here, integrate directly into things like CI processes and workflows. Don't, the worst thing you can do is send a URL to the security product to a developer and say, hey, log in and figure it out. They should have the rationale. They should have the instructions of what to do directly where they're building their application. What type of feedback do they need to have to actually resolve that? And that's the model that, we believe in, and that's the model that Red Hat believes in. And really why they acquired StackRox over some of the alternatives is that we built it from the ground up to do that. And we believe security must be continuous. We believe it must be something that is built in, not bolted on. And this is just this is taken from kind of like a NIST model, if you've ever looked at NIST compliance or things like that. But the idea that security has to be continuous all the way from when you design it to when you build it to when you run it, and then there has to be a feedback loop. So how are we automating? How are you automating security guardrails or security policies to say, hey, we've detected this risky type of configuration in runtime, and then how do we feed that back into the design and build phase to say, okay, let's eliminate that from being an exposed risk as we iterate. So security, this is the thing, is like security on containers in OpenShift is never going to be perfect. It's going to be iterative, just like your application development is now iterative. It's, immutable. Let's build it. If we need to make changes, let's tear it down and let's build a new version. Let's iterate. That idea of, spin up, spin down, that idea of iterating and moving the needle towards perfection, but not necessarily needing to be perfect, is a philosophy that security teams also need to hop on board with, because it's only shortening the amount of time from build to runtime. It's only getting faster, and so the name of the game is really, how do you secure that application lifecycle without slowing down developers? Well, you have to do it in a native way. You have to do it in a way that they adopt it, and you have to do that while being scalable and being able to mitigate risk in a non-risky way. In other words, like your security tool shouldn't rob Peter to pay Paul and just automate a security control, but then pose your entire production deployment and make you unavailable. That defeats the purpose of doing security. You're trading one problem for another. So finding that balance is something that we believe in. We'll see if there's any questions on that approach, and we're going to quickly move into the demo in a minute. Are there any questions? Like, I don't know, Joseph, if you see anything popping up on the chat?
I think we're flowing really good. We're good, clear questions so far. I'm pretty sure there will be a lot moving forward.
Okay, great. This is the last slide, and then I'm going to jump into the demo. As we go into the demo, the way I would position kind of what we just talked about is security for containers on OpenShift or Kubernetes can be broken down into basically 3 buckets. The one on the left is the build phase. So you can think of that as things like, how are you building your images? How are you managing trusted content? How do you determine what types of third-party packages and libraries you include in your containers? What's your strategy around registries, private versus public, or certified registries, unapproved registries versus approved? How do you make sure that there's the right configuration inside your container? And traditionally, this is where you have tools like Jenkins, OpenShift pipelines, Azure DevOps, GitLab, CodeFresh, XYZ, CI/CD tool that's going to be really in charge of pushing images to registries, managing that content, but then also configuring and deploying it to like a staging or a test environment. And that's a wonderful opportunity to insert declarative security policies and say, hey, we want to catch these types of things. So that's a really good intersection for security teams to use a product like ACS to say, hey, we want to know if this is happening, at that build phase. The second bucket, and more broadly is defined as like CSPM. I would simplify it to when you're actually going to deploy your application, is the posture of your environment secure and is the configuration of your application secure? And really that comes down to, in the Kubernetes or an OpenShift world, things like admission controls, additional things beyond the image and the container, what's your service exposure on the application? How are you managing secrets, sensitive data? What's its service account role? How is it sharing that information? What are its host level privileges? What types of network policies do you expect? All those types of things that more broadly have to do with how it's going to run. And then the third phase is kind of the one that I think most security teams are familiar with is runtime security. So, let us know when something bad is happening in our environment. So something's getting executed that shouldn't, someone's scanning ports, trying to move laterally within our network. Like the Capital One breach, right, was in like AWS. Someone was able to use the metadata API server because they got access to a network that had access to that. They were able to steal privileges by calling that metadata API. And then they were basically able to elevate and steal data and sensitive information from the underlying environment, right? So the idea of, if an attacker's in full mode of trying to, they gain entry and they're trying to move laterally, they're trying to do things like, how do you catch that and not only mitigate it, but also how do you do things like incident response? And detecting that can be quite difficult because it's not always easy to understand what abnormal is, right? So we'll kind of get into that. So I'm going to go into the demo. I could share more, but I think the demo is really where it gets interesting. So what you'll notice is we've completely picked up this term since I've joined Red Hat. We've completely red-washed the UI. So if you use OpenShift or you're an OpenShift user today, you'll notice it's very similar to the UI of the OCP console. And so you kind of think of it as like a similar structure where, just like if I'm an OCP and I want to look at my operators, my workloads, my storage, my monitoring, and each of those sections of administration from an infrastructure and platform, same thing for security, except it's based on security use cases. So, I care about my network segmentation. I want to look at my runtime violations, abnormal executions, and dynamic risks. Do I want to look at compliance and some of my benchmarks? Do I want to look at vulnerability management? Do I want to look at configuration management, risk? And then, how do I want to configure some of my policies? I like to start on the risk tab. I think this is kind of like it's the most interesting part of the conversation when we talk about, the analysis of what ACS or what StackRox provides. The quick thing I'll mention before we actually go into this, I'm not going to spend a lot of time on the installation because it just runs like another application inside OpenShift or inside the Kubernetes environment. So what I will show you is what that topology looks like briefly, so you have an idea of like what gets deployed. But basically, we deploy as our own set of microservices in the environment. Today, it's deployed via Helm. Very shortly in the next month, it will be operator-based, like most things with OpenShift. So that's coming very shortly here. But there is a UI API portion to this. There is an image scanner portion to this, and then there is a cluster-level detection and collection mechanism through a collector daemon set that collects some of the information. We also deploy an admission controller to each secured cluster, and there's some other things that take place there. I won't spend a lot of time on this, but just know with OpenShift or Kubernetes, it can be deployed in under 20 minutes. It has its own StackRox namespace, and then when you come in here and you basically want to add additional clusters, you would add clusters to this. You would centrally manage it, similar to, a centralized console that you would have for all your OpenShift clusters, but for security, you would manage it centrally through this UI. So under the risk tab, what this is basically doing is this is prioritizing risk based on all the different attacks that we possibly see in the environment. And so if you think of like the recent pipelines that got hacked, or the ransomware attacks, the crypto miners that we've heard of, like what if I were to want to answer the question in my environment, let's say I own StackRox and I work for a big bank, what application is going to end up with has the highest risk of our organization ending up on the news? And I know that sounds like cheesy or maybe funny, but it's true. There's usually, it's kind of like the 80-20 rule, like 20% of the environment is probably responsible for 80% of the security risk that you're going to see. And it's usually a handful of bad actors or, a perfect storm of conditions, like the Capital One breach or like the Tesla hack where they had an exposed Kubernetes dashboard and a bug that allowed you to elevate cluster admin privileges to the API server. And it's always something that isn't obvious, but has a perfect storm of conditions where, based on all the different vectors, it adds up to a really bad recipe. So what this does is it compares all those different, areas of your environment, and it stack ranks every running deployment based on priority. So if I look at like my Visa processor in my production cluster, in my payments namespace, the first thing you'll see is we come out of the box with about 76 default policies. The way to think about those policies are they're essentially default best practices. So if you've looked at things like a MITRE attack framework, OAuth's top 10 vulnerabilities, stuff like data exfiltration, lateral movement, system modification. Generally, like I put it under the category of like things you just don't want to be doing in a Kubernetes or an OpenShift environment. We measure everything against that. So for the first thing we're evaluating across the environment is, okay, how many of these policies are you actively violating? So like in this case, I'm violating a policy that says I've got a secret using a plain text, an environment variable that exposes a secret in plain text. I've added capsys admin capabilities, which basically allow me to elevate privileges, like similar to a privilege container to my application or my container. I've got root user configured in my image, which violates one of my CIS benchmarks. I have, I'm running a privilege container in my environment. And I've got no resource limits specified. And on top of that, I've also got additional things that I might care about, right? The next thing we do is we actually look at the behavior of these workloads in these containers. So you'll see here a bunch of detected suspicious process executions. And what this is doing is we profile every running container. And here, as an example, I've only got one pod in this deployment. I've got two containers. I've got a sidecar and I've got another container. And what we do on each of those containers is we measure what gets executed, and we basically come out with a baseline of what we expect. So everything in white is allowed. It's part of what happens when the container initializes, part of how it's built. And these things are not expected, the things in red. So what someone's been doing is they're using an Ubuntu package manager to install Netcat. They've launched a reverse shell, and they've started to execute Netcat to scan ports across my environment. And so we've detected suspicious activity. We, of course, look at image vulnerabilities. That's a big one. So if I were to look at these deployment details, and I wanted to understand, its image that it's using, I want to see what are all the fixable CVEs, how many other deployments is it in, where did I add this in the Docker file line in terms of my vulnerabilities. Is it OS based, or is it like a dependency, like, maybe something I copied over from my WAR file or my jar file for my Java application in this case, which includes the struts vulnerability. And we can, obviously detect those things, but we're doing it in the context of the actual risk. In addition to that, we see, things like service configuration. So not only do you have all these other things, but a sidecar container has been deployed in privilege mode. You've exposed the SSH port in your Docker file. So I've added an update instruction in my Docker file that actually exposes port 22, which is really bad because you don't want to do that. You don't need to do that. You would do that through a Kubernetes service if you really needed it. And then I've got a number of, components that are useful for attackers that I flagged. On top of that, my image is over a year old. It's 403 days old. And if that wasn't making, your stomach drop already, the service account that this application is using has been granted cluster admin privileges. So the reason this floats to the top of the list is because when I look at this, I've got privileges at my host, privileges at my container, privileges at the application at the Kubernetes level. I'm wide open to the outside world. I've already got sensitive data being exposed in my deployment. There's vulnerabilities that are very significant. And on top of that, suspicious activity has already taken place. So that's basically from this one application, someone would be able to modify and get to pretty much anything they want in my environment. And obviously we've architected the demo environment to be particularly bad. I would hope in a customer environment you wouldn't see an example that's quite this much of a monstrosity, but you do see things that are like this, right? And this is really at the crux of what ACS is designed to do. OpenShift is really good for infrastructure level security. Day one, you've got everything built into the nodes, built into the platform. You've got IAM, you've got all these controls that you can do. But when it comes to your applications that you plan on running on OpenShift, this is the type of functionality that ACS provides, being able to do risk analysis, being able to detect where you're most at risk of these things. And then what happens next is basically we allow you to designate for our policy engine how you want to handle those risks. But it doesn't need to be manual. Basically, do I want to tie this to my notification-based systems in order to, notify me of these risks to like my SIEM provider? So for example, maybe I want to add, integration into syslog, or I want to be able to open Jira tickets when certain things happen. Maybe I want to send notifications to Slack. Maybe I want to, send emails. Or, maybe one of the things I even want to do is I want to integrate this into other types of workflows, like at the build stage, for example. So one of the things that a lot of customers like to do is they like to say, okay, you've got all these default policies. Well, how do those work? So like, if, for example, if I take this fixable CVSS greater than 7, what you'll see is this is basically, it's a build and deploy time policy. And so if I click into this and I look at this right now and I click edit on this policy, you'll notice that whether you're creating a new policy or whether you're editing an existing one, there's a bunch of different fields that you can enable for this policy. So I can designate a severity level, a name. There's a rationale and a remediation about this is from a security perspective. Maybe part of what the security team wants to do is say, refer to customer XYZ / InfoSec vuln management policy. Maybe you want to include some sort of metadata into this. Maybe you want some parsable field that, if you're using Splunk as a scene, you want to, tie this to some sort of parsable field that you want to go to your, through syslog. So you say like, oh, I will also want this to be part of like a SOC 2 query. So I'm going to add this, custom category. I'm going to tie this to a notifier. Maybe I want to restrict this to a specific cluster or specific namespace, exclude by scope. And so in this case, what I'm basically doing is coming in and I'm defining all of the context around that policy, and then you'll see because it's a default policy, it already has certain criteria in place, which basically says this has a vulnerability that's fixable and greater than equal to 0. Sorry about that. Just telling someone I live with to be quiet because they're being noisy in the background. The benefits of working from home, right? Right, Joseph?
We all can relate, Eric. It's not just those noises. Sometimes kids, pets, and everything else.
Yeah. If you see me going on mute and barking over my shoulder at someone, that's
why.
Good, Eric.
Actually, Eric, I think there is some really good questions in the chat.
Yeah.
So if I can, Joseph can maybe read it.
Yeah, there's a bit of questions about network. I'm not sure if you want to answer those now or reserve it when you go on the network side of the demo.
Yeah, let's go there now. I think that probably answer it.
There's actually a question from 2-1 on that one regarding how StackRox provides network segmentation. Is it using IP tables? And there's also there's also a follow-up on that one. Kubernetes network policy does not offer micro attack AT&T framework. How can you secure the app fully distributed? That's the one.
Yeah, no, definitely. Yeah, so the way I look at it is networking is multidimensional, right? So network policies are going to solve one aspect of your overall network security strategy, but there's also additional things that will present risk, like even including the policy that we're about to create, right? Like one of the things that I might want to do is say, hey, like I really care about these vulnerabilities, but I also want to detect it if it's running in a publicly exposed load balancer. So I want to create a specific policy that's configuration based, that's looking for something within a configuration. And that's traditionally really difficult to do, like with a security product, because usually you have like one set of policies that does this, one set of policies that does this, and it's really hard to like combine that in a single policy. So something like this would allow you to basically say, I want you to create some sort of policy that's looking for this type of risk context and what you want to do with that. Like, so in this case, for example, when I create this, I have the option of basically turning this on at build time or also turning this on at deploy time. If I turn this on at build time, it would have an enforcement behavior or would actually fail the CI/CD build, like in something like OpenShift pipelines, return and exit to that pipeline and give the developer the things they need to fix. If it's at deploy time, it's basically saying, hey, we're listening to the API server, someone tried to schedule something with a fixable CVE above 7, and it's running in a publicly exposed load balancer. We're going to actually deny that, not allow it to run. And in the same policy, I could set up something like that. So to answer your question, like the MITRE ATT&CK framework has a lot of dimensions, and it's going to require multiple types of policies to cover that. And out of the box, the different things that we do, like around the different types of things that we look at and how you choose to enable or notify on that will cover a large majority of those sections, right? In terms of like what you actually want to look at, both at the build time, the deploy time, as well as at runtime. So people doing things that might be privy to things like system modification, set UID processes, system de-execution. All of those are default policies that we detect on. Going into like the network segmentation question, this becomes it's a question of context, right? So what we actually do is really interesting. We map out everything that's running in your environment against the declarative configuration for how you have that configured. So under the network graph, basically each of these is my namespace. And so you'll see here, like this payments namespace, each one of these is a box, represents my namespace, and each one of the dots within that namespace represents a running set of pods or deployments. And so we were looking at that Visa processor as an example. And immediately what you'll see is like if I hover over this in the graph, I'm going to see high-level information on things that I would care about, like directionality, ports, and protocols. So I can see I've got an ingress from another pod in my payments namespace, and I also have ingress coming from my operations environment. If I click into this, what I'm going to begin to see is additional detail on those network flows. So this detection happens automatically. And basically what I can see here is that similar to how we like baseline the process executions that we showed you earlier in the risk tab, we do the same for network detection. So I see that I have a connection from a jump host that actually got flagged as anomalous. What I also can see is that this has no existing network policies defined on it. I can also see the configuration of everything, the exposing service, the port configuration, exposure level, its listening ports, how it's configured. And this is, and basically now using this information, what I'm going to begin to do is I'm going to begin to say, okay, let's actually generate and simulate a network policy that is based on that baseline. And so what this is going to do now is it's basically going to, it can auto-generate a network policy that you can apply in the environment to basically segment the network and get the right segmentation layer at this. And to answer your question, Tuan, it is looking at the L3 to L4 traffic of the pod-to-pod communication in terms of like what you're doing at network segmentation, right? Like this isn't designed to be an L7 firewall, and you're still probably going to have some sort of web application firewall at L7 that's doing, you know, some type of firewall at that level, right? In terms of like where we see opportunity to do additional things, we have plans on the roadmap to integrate into like the OpenShift service mesh and Istio. So being able to do things like auto-generating Istio policies or destination rules through the Istio orchestrator, doing something like that is particularly interesting. But our philosophy is this, like rather than being the tool that inspects everything at L7 and tries to flag what bad is, we think that there's an advantage to being able to define what good is, and it's much more scalable, it's much more performant, and it breaks a lot less. The harsh reality is when you do network detection, L7's nice, but doing network segmentation that way is very cumbersome. You know, like for example, and I'll share this, Reddit is a customer of ours. If we were to detect every single IP call and every packet, you know, that was happening at L7, their production environment would probably fall down by the sheer number of connections that are taking place in an environment like Reddit. It's not a particularly useful approach when what we believe is the new way we want to think about it is like, hey, you now know what you expect your application to behave like. So why don't you declare in code what you want that to be? If it can only communicate with this, by default, deny everything else, right? And that falls in line a lot with like these patterns and themes of like zero trust, right? Like, let's get away from the traditional like IDS, IPS type of like mindset, and let's evolve into a network segmentation and detection strategy that clearly defines what we expect the behavior to be and notifies things that fall outside of that. That's still important, but we want to move in the direction of innovating on that declarative network approach, right? And that's why we do it this way, because what this allows you to do is eventually move into a shift left model where, you know, the nirvana state is like, imagine now if we could ship all of our applications with default network policies. That would be great. You know, are we there yet? Probably not, but eventually it would be really nice for, you know, the network policy to be part of the source code that says, hey, like this is the profile of what your application does. And I think in terms of like what ACS does, it helps. It's a really difficult thing to do, right? To both visualize the behavior and the profile of like how your deployments communicate, but then how do you iterate and modify network policies? How do you make sure they're doing the things you want? You know, are you going to automate this right away? Probably not. If anything, what you'll probably do is you'll probably generate a network policy and, you know, share it to something like change control, and so someone can review that. no, we're not going to like automatically be applying anything here. So hopefully that helps, Juan. Really, really good questions on that front.
Yes, thanks for that.
Great. So I think in terms of some of the other things that we can talk about, kind of going into more of like an active violation. I always kind of like showing this because it kind of shows you like the proofs in the pudding. So for example, let's say like I wanted to go ahead and let's like exec into a pod as an example, begin doing bad things, right? So if I take like this monitor pod and what I'll do is dash P monitor, I think it's called monitor. Oh, no. Been a long day. Been a long day. Keep going up. I don't need the dash C. This is why I should have done this before. There we go. Okay, so now, what I'm going to do is, like if I go back here, right, so now you'll see immediately it's already detecting like, hey, someone exec'd into a pod, right? Here's what happened. Here's the timestamp. I can continue to do like some nefarious things like, let me get an apt-get update, apt-get, I'm going to start installing crypto miners on Red Hat's demo nodes. That's how I make my money. Just kidding. To install. You guys know, but I have 1 million CG miners installed.
Mm-hmm.
Now I'm going to run, unable to run. What's another crypto miner I could install? If anyone has one, I wasn't able to find that. Like, what is it? Miner. Anyway, you guys get the point. So now, basically what you'll see here is, the detection happens in real time. I can see now everything that, someone tried to do, install CG Miner, the container ID, the timestamp, a lot of really cool, incident response flows if I wanted to come in here and, do something like, basically say, hey, go ahead and, maybe I want to create a violation comment like, Joseph, you tried to install a crypto miner.
Oh no, someone caught me.
And it's like a perma thread, that's like there.
Goodness.
You could export this to CSV, you could integrate this and it goes to a scene provider. But then like the cool part is like the actual policies, right? So like maybe one of the things I want to do is say, hey, next time someone does this, I'm going to turn on this policy and I want it to go ahead and I want to enforce it at runtime. So now, I'm trying to do like an apt-get update. What this is going to do is it's actually going to tell OpenShift to kill the container. And so it locks the attacker out when that detection happens, and I can do a kubectl get events. And if I do this across all namespaces here, what you'd see in the events is that, security enforcement action violated a policy and was killed. One of the other things I could do is I could actually do this through admission controls, right? So like that's one way to mitigate it at runtime. Say I want to take the policy and say, hey, turn this on for, I don't want people execing into pods inside, inside my, sorry, just totally spaced, inside my production system, right? So I'm going to take this policy and, I want to catch it further left. So actually what I want to do is I want to turn this on so that no one can do this through the admission controller, try to exec through this again, and oh, sorry, I got to get the pod again. So let me actually kill the pod and spun up a healthy one, which by the way is the way you want to do it, right? So I'm not breaking the application in the previous example. a lot of tools kill the container. But if I'm a developer and that happened, what you would be seeing here is 0 out of 1 pods running, crash root back off. You just broke your production application. Congratulations. The right way to do it, tell Kubernetes to kill the pod. Same effect. You kill, you mitigate the security attack. Those are the types of native ways we believe it should be done. And now, now if I take this, this new pod, and let me try to actually, try to go and actually modify this. I'm going to exec into this now. What it should do is it should actually prevent me from doing this. And so, when it actually came back and said, hey, sorry, you have a policy, we're not allowing you to do that. Here's the rationale. Here's the remediation. If I want to go even further left, I could say, well, let me actually tell developers to remove a package manager in their image at the CI/CD stage. So I'm actually going to turn this on at the build stage, and I want you to go ahead and actually tell me, in OpenShift pipelines, as I'm building the image, tell me to remove that. And so what I would see here is basically if I go to like a pipeline demo, we have a CLI-based utility that's basically a binary that calls to the StackRox API, and it will basically run like a deployment check against my deployment and come back and say, hey, here's everything that's wrong with your deployment. Here's what you need to do. Remove the package manager. And so basically the idea here that I want to leave you guys with, I know we have about 4 minutes and we want to take some final questions, and we've covered a lot, is you have all the risk analysis, you have the behavioral detection, the risk mapping, the network mapping, the policy detection. But the real value is a security team that wants to do DevSecOps can come into OpenShift, come into Kubernetes. They can say, this is what we want good to look like. Let's put it in a policy. Let's notify it here. Let's tell them here. Let's have it enforced this way. Do this. Set it. You have automated controls, automated mitigation, automated notification, and your developers begin to build things the right way because we're prescribing them what they need to do. Like even here, put this in your Dockerfile line. It's brain dead. Like put this in your Dockerfile line, remove it before you go to production. We're not just saying, hey, you have an issue. We're educating developers on Kubernetes in the process. These are the best practices. This is what you do. So hopefully that's been helpful. I just drank a dark roast coffee before I did this demo, so apologies. The U.S., I'm from Boston originally, so talk a little fast to begin with before I moved to California. But hopefully this has been useful, guys. I'll hand it over to you, Joseph, if anybody has some final questions. You want to take any polls or anything like that? You can go ahead and do that.
You're on mute, Joseph.
We can't hear you. No, Joseph, we can't hear you. There you go.
Can you hear me now?
Yes.
Yeah.
All right. Sorry, I was just saying that some of our attendees are saying that under current security implementation, they are most concerned on the build and the runtimes, Eric. So it's just very appropriate in your demo that we cover those aspects of security, both the build and during the runtimes. And I think a lot of our participants and attendees today are very matured when it comes to OpenShift. I think they are OpenShift Jedi and Masters, and they will be curious to know how does it complements the existing, for example, toolings like compliance operator that we have in OpenShift.
Yeah, definitely. I think just to kind of give you guys a little bit of like an example of the roadmap and kind of where I think this is going, and I'll answer, Tuan, I'm going to answer your question as part of this too. So we do have a roadmap that is basically very heavily integrated to. It's going to be heavily integrated to OpenShift, and so the way I kind of look at things like the compliance operator is the compliance operator is really good at like right level operations. So actually, really meta level policies to say, hey, if you detect the CIS, security benchmark in OpenShift, change this. We've developed our compliance more from like a governance and auditing and a visibility perspective. So the visualization on compliance is much more, that's like what customers use us for. And we want to bridge those. So actually what we're going to be doing is integrating with the compliance operator within the next like 4 to 5 months. We are transitioning over to having default CIS benchmarks for the OpenShift security benchmark, looking at like OpenShift API server audit log detection, increasing the amount of events we listen to for that. We've already actually been rebranded or have had the Red Hat scanning certification on our image scanner. And then we're going to make some additional adjustments in the short term for OpenShift integrations to things like risk policy and the network graph. But there's a lot of really cool stuff coming. So I think the way I look at it is like OpenShift has tons of awesome stuff. We want to take advantage of it, enhance it, and then add to it. And that's the way I look at it. So we'll solve the gap of like application lifecycle and container security on top of OpenShift, and where we can leverage existing workflows and platform level integrations to make it seamless and easy is going to be, I think, to answer your question, Tuan, that's going to be a huge differentiator for someone like Twistlock. They're not going to be able to do that. They're not developing as tight of an integration to OpenShift, and that environmental and platform level approach is just not going to be there. The other thing with Twistlock would be everything we talked about. Like the approach is just fundamentally different. Network policies versus IP tables, isolated policies versus contextual policies. Killing containers versus killing pods. A lot of it's just like the mindset of the security tool, and like Twistlock today, to me, seems like a lot of stitched together features and functionalities that kind of operate almost in like a black box. Is how I look at it. And it's useful, but I think they went more of like a mile wide, 2 inches deep, where we went a quarter mile wide, 3 feet deep, right, on security for Kubernetes. That's the best way I would put it.
That's really good. And thank you for answering Tuan's question. There's just one more just to elaborate on Daniel's question. In the AWS world of services, is there like a comparable or competing service that should a customer be running on ROSA or their own OCP on AWS? I think he's trying to elaborate on, he's trying to look on how to be able to deflect if a customer is running OCP in AWS, that they don't choose an alternative service that Amazon offers.
Yeah, I don't think there's any service they offer. They traditionally partner with like the main competitors that you've already looked at, like people like Aqua, Twistlock, Sysdig, and StackRox. I mean, those are what kind of the big four. If you're to look at, each cloud provider has some generic security that they provide, but it's very limited, and it's mostly around like etcd encryption or secrets management. Things like that, but not full lifecycle security features. So there's not really a competing offering. And then more specifically to Rosa and Arrow, it's not that we don't support it today. You could run StackRox or ACS in those environments, but what Red Hat wants to do is really be intentional with the managed service approach, because the way that security is consumed in that type of offering is different than a self-hosted environment and someone who's just running like OCP. So we're trying to figure out how we would specifically cater to that customer profile. It's less of a technology problem and more of like a go-to-market strategy coordination, in my opinion.
That's a really good way to put it. And thank you so much. I think we are a bit over time, but that's how interesting Meetup goes. We normally exceed the standard hours, but thank you very much, Eric Bannon, for joining us all the way from the US of A. And thank you for gracing the New Zealand Meetup. And hopefully we get to speak to you more often, some of the attendees that we have at the moment. And thanks, everyone, for attending. Again, be safe. Just stay at home and always wash your hands and wear your mask. And thanks as well, Mike and Eric. Mike and Ash. And see you again next month on the next edition of the OpenShift Meetup. See you, everyone. Have a good one.
Bye, guys.
Thanks, guys.
Good one.